So today we're going to get quick and dirty into the slides, and then we're going to jump into demos for the rest of the time. We only have 30 minutes together, so I just want to make sure we cover as much as we can and really talk about the Dapr open source project, how you can get up and running with it, how it enables developers. So I'm curious, how many people have heard of the Dapr project before? Wow, okay, this is super exciting, like completely greenfield. We love this. So I'm gonna go from 0 to 100, and hopefully at the end of today, 30 minutes from now, you'll walk away feeling very confident in what Dapr is and how it can enable you. So curious, how many of you are actually back-end engineers, developers, writing code most of the time? Perfect. I think you'll benefit really well from this then. So what can you see? Can you see this? You can see a slide, right, the intro? Okay, perfect. My name's Kendall Roden, by the way. I am a product manager at a company called Diagrid, and we basically build products to enable people to use the Dapr open source project at scale on top of Kubernetes. And then we recently released a new product that essentially allows you to use a set of open source APIs to build distributed applications regardless of hosting platform. So no longer constraining Dapr to running on top of Kubernetes, but now you could use other SaaS or PaaS-based services in the primary cloud providers. So at one point or another, probably in the past several years, you've all had some level, trying to make sure I'm not screaming at you guys. How many of you have ever been part of like the cloud native hosting conversation, right? Like you've heard the conversation around IaaS and PaaS and should we go serverless and how much do we want to abstract away from developers and how much infrastructure do we want to manage? Like, is that a pretty familiar conversation? I would say, yeah, most of us have probably gotten in at least one or two debates on what cloud native really means and does it have to be microservices and Kubernetes? But essentially, one thing that we find that's missing from a lot of these conversations is where developers fit into this narrative, right? How do we create and enable developers beyond just shoving things in a container and running them on Kubernetes, right? It provides us a level of infrastructure portability across cloud providers and obviously on premises as well, but we don't necessarily just have portable code, right? Our code still has dependencies, libraries, reaching out to specific services, and that's not necessarily something that translates from cloud provider to cloud provider, even environment to environment. So that's really where Dapr was created and comes into play, is by creating and enabling a consistent set of APIs and an infrastructure layer, or excuse me, an abstraction layer through which developers can code against infrastructure without bringing the details of that infrastructure into the application code. So having a way to interact with consistently infrastructure providers without that SDK logic ever having to come into contact with your business logic. And this is really great because it does provide this new level of portability at the application layer. So we're no longer just taking all the dependencies, wrapping them up in a portable package, but we're actually taking code and making that code portable so that we don't have to rewrite that logic whenever we move from cloud provider or service provider, from one to another, or even from the local development workstation where we're leveraging developer-centric services and then moving toward a more production-ready scenario where we're using, maybe Kafka instead of something running locally on Redis on our local machine. So that's what Dapr is, the distributed application runtime. Are any of you familiar with the Cloud Native Computing Foundation? Is that a pretty familiar entity? Okay, awesome. So Dapr is an incubating project in the CNCF. So that's where projects like Kubernetes have been incubated and then successfully launched into graduation. So a lot of open source projects tend to gravitate toward finding a place in the CNCF because it provides a license that's guaranteed long term. So there will never be like a paid version of Dapr that you have to subscribe to, right? You can have consistency and confidence that the project will always be open source and free to use. So with the distributed application runtime, when we're looking at the actual architectural model of how this runs, how you can use it, it runs as a sidecar. So if you're familiar with Kubernetes, do we have any Kubernetes software engineers in the house, infrastructure? Okay, cool. So if you're running on Kubernetes, the way that this looks is that you'll basically deploy a pod, which hosts that container with your application code, and then you'll also have a sidecar. So this is probably a familiar paradigm if you're familiar with like the service mesh primitive, where you have a single sidecar that runs alongside each application. And that's how Dapr operates as well. And then it provides a consistent API layer. So through HTTP or gRPC, you can communicate from your application across localhost to the Dapr sidecar and access a set of distributed application building blocks. So If you've ever built distributed applications, you've probably written a lot of code to handle things like publish-subscribe communication. How do I do secure service invocation with MTLS? How do I do state management, right? I want my applications to be able to securely access and retrieve state. I also want to do things like maybe even distributed actors, running stateful workloads at scale, or even implement workflows. So if you've heard of like Temporal, right? They provide a workflow engine. Dapr actually has an API that codifies the workflow, basically management process. And so I'll show you a little bit of what that looks like. But yeah, we basically provide a lot of these patterns out of the box as APIs that you can consume. And then on top of that, you get a set of cross-cutting concerns that are baked into the APIs. So things like resiliency, right? I no longer have to code, for me, I'm most primarily a .NET developer. I don't have to write any poly logic to basically say I want to create a circuit breaker, or I want to, retry this particular call, or I want a particular timeout. The Dapr APIs provide that to you in a declarative sense. And then you can also set like security paradigms. So we have like API token validation, app token validation, things like scopes, which allow you to configure access to backend infrastructure providers. And ultimately, most customers run this on Kubernetes, and it's completely application code agnostic. So regardless of code or framework, you can call these APIs. So if we're looking at it in practice, making it a little bit more practical and those building blocks and turning them into APIs, think of things like v1 invoke. This would be the way that you would call out to other services running within the Kubernetes cluster, or v1 state. So take out all of that Redis logic, take out all of AWS S3 logic, and instead you're going to call out to the v1 state API, and the Dapr sidecar will broker and facilitate a connection to whatever backend infrastructure you choose. And then the same goes for the other APIs, very consistent, have created like a very clear coding model around these things, v1 publish, v1 secrets for secrets retrieval, all of which really provide that abstraction layer to make sure your developers aren't bogged down by infrastructure choices that are made by the platform team. So this is kind of a picture of all of this together, right? Think of an actual microservice-based application or even modular monolith that has a variety of different functions it needs to perform, like retrieving secrets or maybe even being invoked based on an event that comes into a particular database, or make a publish to a broker, right? All of these would traditionally be done by creating direct calls to those backend services, wiring up the authentication mechanism. But with Dapr, what you get is that consistent layer with all of the Dapr sidecars, and then you get that abstracted API call. So now it doesn't really matter what broker I'm using or which database I'm using. Instead, I focus on creating really clean, reliable code, and then the platform team can provide me with whatever backend infrastructure based on either the environment or the changing requirements that application has, or even, we all know in the cloud space, a new service that's created that might be a better fit for what we're trying to accomplish. So how does this actually work on the back end? So when we talk about the infrastructure swappability layer, how do we implement that? And the way that's implemented is through a series of what are called Dapr components. So I essentially tell the Dapr sidecar, hey, when I call out to the v1 state API, use this particular component. Or when I call out to the pub/sub API, use this particular component. So these are all named Kubernetes resources that your sidecar can pick up. Depending on the URL of the API call, it will know which component to use. So there are over, I think, 135 different components supported today across all of the different APIs, which once again is really great. And because it's completely vendor neutral and community driven, we see new components being added every day as new services emerge, and especially even the new kind of upspring of serverless offerings that facade some of the backend infrastructure. Even those can plug and prove as a Dapr component very useful. So are y'all excited? We're going to do only demos from now on. So we got through those pretty quick. So this is what I'm going to show you. So I thought it was good to kind of just set up how Dapr works locally, and then I'll kind of progress into Kubernetes. But essentially, the only requirements for getting up and running with the distributed application runtime or Dapr is doing, you're going to install the CLI like you would almost any tool, and then you're going to run a Dapr init. And what this Dapr init command will do is essentially fire up and start running Dapr on your local machine. So it's going to pull down some container images. You can run it without Docker or without like a Podman. You can run it in slim mode, but what's really nice is what this provides is a default pub/sub broker and a default state store component. So it'll use Docker, it'll run Redis, and it'll basically wire up the sidecar to automatically use that local Redis instance. So you can get up and running with the APIs and then obviously swap out that component without changing the application code. And then the other thing we're going to do is run a Dapr run. So this is really the command that's going to launch your application and the sidecar process. So you don't have to be running on Kubernetes locally. You can just be running, your application process, and then we'll launch that sidecar process, which is Dapr. And then ultimately, when you deploy to Kubernetes, these would be running in the same pod as containers. But what's nice is the Dapr sidecar is basically going to introspect a file that we pass, and that file has a set of Dapr resources in it. So this is going to be all the components we want it to load, which are going to inform the API calls, and then other cross-cutting concerns, things like I want to create a new Dapr PubSub subscription. So I can programmatically or declaratively subscribe to one of these components without changing the application code should I choose. And then we also have like resiliency policies, for example. So it's going to pick up resiliency policies I apply and target particular components or applications whenever I'm making those calls. So this is what you're going to see locally. So we're at 12:36. I think I have, how much time do I have? Somebody keep me honest. I've been talking for 10 minutes. We got 20 minutes left. Okay, we're doing good. Are there any questions at this point that anyone wants to ask? Is it adding up? Is the mathing? Hopefully. Okay, awesome. Okay, so we're gonna dive directly into Visual Studio. And is the audio still okay? I feel really loud, but okay, as long as y'all can hear me and it's not too much. Okay, so I'm dropped into Visual Studio Code. Don't get too bogged down with any of the details here. Is it zoomed in enough? When you zoom in a little bit more, sometimes it gets hard to see, maybe a little bit. Okay, I'll do a little bit more, but it might make it a little bit less legible, but that's okay. We work with what we have. So the first thing I'm going to do, like I said, is run my Dapr init command. I've already installed the CLI. And because I already have Dapr initialized on my local machine, it's basically going to tell me, like, hey, you already have the latest version of Dapr installed. Like, you're good to go. You don't need to do anything else. So if I didn't have this already, what this initialization process will do is the first thing it's going to do is create a Dapr folder for me with those default components. So let me show you a couple things. So one is I'm just going to cd into the directory that's created by the initialization process. And what you're going to see here is I have this components folder or directory. So if I cd in here and I take a look, I can see I have a pubsub.yaml and a statestore.yaml. So these are going to be those manifests that inform the API. By default, use Redis to target whenever you're making API calls. So if we open these up and just take a quick look at them, I've moved them into my local directory to modify them. But this is essentially what a component looks like, right? It's a Kubernetes manifest definition, essentially. And it has a name, so the name is really critical. That name becomes the unique identifier for this particular component. And then it has a type. So remember when we talked about like the swappability aspect? This is the only place where you're going to have any reference to the backend infrastructure. There will be no code reference at all in your application. So this could be pubsub.redis, pubsub.aws.snsSQS. It could be pubsub.azure.servicebus, right? The list goes on. There's a ton of supported components. And then based on the component type, you'll have a series of configuration values you can pass in, things like consumer IDs, right, for Kafka. So there's going to be different metadata depending on the backend infrastructure that you're targeting. And you can see out of the box, it's just calling directly to the Redis local host, which happens to be running on top of Docker in a container. And that's why the state store and PubSub look the same, right? Because Redis Streams is a PubSub provider, and then you have Redis, the state store instance. So I've moved these over into my local, my local directory where my code is sitting. And that's really where I want to get into kind of the nitty-gritty of, let me see if I can get back here. Okay, cool. So now we're dropped into Visual Studio. We have some components set up, which I moved into this local Dapr resources folder. But I really just want to show you what the code looks like first and give you a taste of what it looks like to make use of the Dapr APIs. So I have two applications, both are written in .NET, but like don't let that constrain you. I just didn't want to overwhelm by adding a bunch of polyglot languages in a 20-minute demo. But essentially, we have one consumer and one producer, right? So the objective of these applications, the producer is going to publish a message to a PubSub broker, and the consumer is going to receive that message and store it in a state store, right? So pretty basic, setup here. So if we take a look at the actual program, it's super simple, and we'll take these breakpoints out in this search just to make it a little bit cleaner. So this is really the few things that you want to note. So one is I'm using the Dapr SDK. So obviously the SDK provides a wrapper around those V1 state, V1 workflow APIs and just makes it a little bit friendlier to use. But I can call them directly using HTTP or gRPC. I don't have to use the SDK. But the Dapr client will essentially start up, and the Dapr client's what I use in order to communicate to the Dapr sidecar process that will be running alongside my application. And this is the only line of code outside of the client instantiation that I have to create to publish the message. Can we just clap for that? That's pretty impressive if you've ever published to a broker before. Yeah, it's kind of cool. I mean, your first thought's gonna be like, it can't be that easy. And my challenge to you would be like, try it out, because it really is. But yeah, essentially we're gonna use the Dapr client and we're gonna publish an event. And the two pieces of information we pass in is what is the name of the pub sub component, and then what is the topic on that component I want to publish to. So if you remember, we had a component for Redis. So this is saying, hey, I want you to go find that pub sub component named pub sub and use whatever that backend infrastructure resource is to publish this message and do it on the orders topic, passing in an order payload. So it really is that simple. And then we have a second application that's going to be running as well, and this is the consumer application. So similarly, super basic, right? I have a single line of code that's receiving that order that comes in, and it's basically going to take that and store it in the store. So if you remember, we had that Redis state store running locally. It'll use that out of the box because I called that component state store. Now, I can switch out what that state store is, which I'm going to show you as well, but super basic code. And there's SDKs for, I think, 7 different languages. We have Rust, Python, Go, Java, so like it's very, language agnostic, super friendly in that regard. Okay, awesome. So the only other thing that I want to show you is this component manifest, right? So we already looked at the pub/sub Redis component. So you can see here, it's called pub/sub Redis. We have pub/sub.redis as the type, and then we also have scopes. So scopes are a primitive which essentially allow you to dictate which applications can access a given infrastructure component. So that's just another kind of added security measure there. And then we also have the state store, which once again is going to point to that Redis instance. And then there's a couple of things that I added that I wanted to highlight, and one of them is a declarative subscription. So how do I actually make sure that the consumer receives the messages that were published using the pub/sub API? And I can do that using either programmatic subscription or a declarative subscription. So in this case, I'm using a declarative subscription, and I'm going to say, hey, this is called the pub/sub-redis subscription. It's going to listen on the orders topic on pub/sub-redis, right? Like that component that we already specified for Redis, I want to listen to the orders topic there. And anytime a new message gets delivered, I want you to send it to this particular route on the consumer application. So like pretty straightforward, once again, really nice. You don't have to change your code in order to do that. So what I want us to do is I want us to actually wire up these applications side by side. So there's multiple ways I could do this. One is I can run each individual application with a single command and launch its process. I can use like my debugger and then just run the sidecar to connect to the debugger. Or what I can do is I can use a Dapr multi-app run file. So if you've ever played with Docker, it's kind of similar to Docker Compose, except there's no container dependencies, right? The only objective is, hey, I want to run 2 applications, one called producer and one consumer. I'm going to run them on these particular ports, and I want you to launch the Dapr sidecar alongside these applications. So I'm just going to do a Dapr run, and that should wire this up for me, and it'll send all of the logs to the same console. So we'll do, first we need to get into that directory where the application lives, and we'll do a Dapr run and pass in that file. Oh, I Dapr run. We love that, very eager. But here we should see, cool. So I'm going to zoom out a little bit just because it's a little unfriendly. But what I want to call out is a couple things. So you're like, whoa, that's a lot of logs. I have it on debug, so don't panic. But there are some really good things to call out whenever we do start these up. Okay. So one of them is going to be, the first thing that we see is we're starting a Dapr with the app ID of producer, right? So this is going to launch the sidecar process for that first app. And what it's going to go through and do, it's going to start loading some of these configuration resources that I've sent into it, right? It's loading resiliency policies. It's loading a local file secret store, so I can actually retrieve secrets as well using the Dapr API. And when I'm running locally, I can get it from a local file. And when I'm running in Kubernetes, I could do Kubernetes secrets or HashiCorp Vault. Once again, list goes on and on. It also found a component for pub/sub AWS, and pub/sub AWS is actually going to be the component that I swap out the code to use. Right now we're using that pub/sub-redis, and we can see it found the pub/sub-redis component. So all of this looks good. So the goal is really just to make sure the components we expected to get launched got launched, And then once again, we'll see application logs as well. So we can see that our app is up and running on 5200, and then the consumer is up and running on 5300. So everything should be pretty good at this point. What I need to do is make sure that I pass in the correct environment variable here. So let's take a look at this Dapr run. So one thing I didn't do, and this is something good for me to know, right, is I need to pass in the environment variable that tells it which pub sub broker to use. So if you remember, I'm going to use the Redis one. So I think right now it's hard-coded to use one called pub sub. But what I'm going to do is in my producer, I'm going to add one more environment variable here called pub sub name. And we're going to pass in the name of this pub sub Redis component, because this is the one we want it to use. So I forgot to add that in, so we'll do that. Perfect. All right, so I'm going to rerun these just so it picks up the new environment variable that I want it to pass in. And then how about we go ahead and test these out? So what I'm going to do is I'm just going to post a quick local command here. I'm going to do a quick post to the orders method on the publisher. And then ultimately, we want to see the subscriber receive that message. So I'm going to send this request, and that's exactly what happened, right? We see the producer successfully published the order number 12 to the topic orders, and then we see that the subscriber picked that up and successfully persisted that order message in the state store. So once again, we didn't see any crazy code, any Redis inside of our actual application, but if we take a look, I'm going to pull up Redis Explorer, probably should have, here we go. And what this is going to allow us to do is just see that it actually did call out to that local Redis instance running inside of my Docker container. So if we pull this up here, and I probably should have cleared this out, should have flushed all the keys, but if we look at orders, we can see the stream. So we can see that the message was published, right, through Redis streams. And then we can also see, if we go to, let's see. If we go to the consumer, we can see that the consumer stored a key of 12, and the data inside of that was the order ID 12. So not only did the message get successfully delivered through the pub sub broker, but it also got persisted within the Redis state store. So what's cool is, how would y'all feel if I just like swapped this out and we use AWS instead and I don't change the application code? Nice, don't get too excited. Okay, so all I'm gonna do this time is I'm actually going to change that same environment variable. So maybe it was good that I showed you all this before. So instead of using pub sub Redis, we're going to use pub sub AWS, okay? And if we take a look at the Dapr resources, we can see a little bit more complexity in this particular component. So we're using the SNS component for AWS, so that's their simple notification service, simple queue service. And then we're also passing in some secret values from a local file. So my goal here was to abstract away the authentication credentials so that you wouldn't see it as an audience. However, what's nice about this is I can swap out the secret store, and that secret store could point to Kubernetes or Azure Key Vault. The list goes on. And if we look here, it's actually using another component. So if we look at secret store, it's using a file that's located here, the secrets.json, and it's basically picking up and loading those secrets. And then once again, I can swap out that implementation for something more production ready whenever the time comes. So all we did was swap out pubsub-aws, and we're going to run the application again. So no code changes, no nothing. We've gone from my local machine. We're deployed on top of an EKS cluster, let's say, and we're going to call out to SNS SQS. So I'm going to make the exact same call. And what we can see here is it successfully published order 12 to topic orders using AWS. So I think I may have the broker up, just so y'all can see. So you can see here it's actually making use of this topic, and what's nice is you can actually give it permissions to go in and create dynamically the topics and create dynamically some of these resources. So if this topic didn't already exist, it would go out and actually create that topic on my behalf. Or in the metadata config, I can say, hey, I don't want you to have permission to basically auto-generate resources within the broker. But yeah, so very simple switch, no code changes at all, and I'm using a completely different infrastructure provider, which is pretty compelling. There's really nothing else out there that lets you use something like this today. And then how are we doing on time? We got 5 more minutes. Cool, I got more for you. Are you ready to see it? Are you excited? How are we doing? Okay, cool. I hope y'all are liking the more demo forward. I know 30 minutes isn't too much time. But okay, wanted to show you a couple of other things. So one is I've changed out my local, actually I could have done this right now. So if you remember, I changed out the pub sub to use AWS, but I'm still using the state store running in Redis, right? I didn't change out that component. So let's say that and I don't even know if I actually practiced this one today, so fingers crossed it works and I got everything set up. But hypothetically speaking, if I do a Docker PS, I can see that I have this like Redis, this Redis container running, right? It's called Dapr Redis. Sorry, that zoom out really is fun stuff. But we can see we have Dapr Redis running. I'm gonna stop Redis. So what that's gonna entail is it's gonna kill the state store, and then we're basically gonna see if the calls will retry due to the resiliency policy that I've created. So, and the one thing I do wanna do, I wanna remove this component from the pub sub provider, otherwise this won't work out. Give me just one second. Okay. So we're gonna run this one more time. Perfect. So what we should see is we're gonna go do a Docker stop, and we're gonna kill Dapr Redis. So what happened is, oh no, dang it. Okay, this loaded that component, 1 second. The publisher starts yelling, which is actually pretty good, but we don't want it to yell in this case. Let me just remove this pub sub provider. Okay. We love a good live demo. It's always great. Okay, we're gonna do this one more time. And then we're gonna kill this again. Okay. Fingers crossed. Okay, so we're using the AWS pub sub, we're using Redis as a state store. I'm gonna publish a message, and what we should see is that the state store obviously struggles to save it in Redis because it's not available. So we'll see if this consumer application, if everything's up and running. Let's see, am I even running it? Consumer. What did I miss? Anybody know? I know what I did. It's the subscriber, right? Remember, I had my subscription pointing to a different component, so I need to switch out the subscription. So that's what I'm gonna do now. Still got a couple minutes, no sweat off my back. We've done this before. So we're gonna go into the subscription, and what we're gonna do is point this at pub sub AWS, right? That's pretty critical because otherwise it's subscribing to a component that no longer exists. So we'll try this one more time, fingers crossed. Everybody cheer for me, get excited. Okay, and then I have to start this. Because otherwise it's not gonna start up, right? If the initialization process will fail if the state store is not available at startup. So what we really need to do is for it to be healthy and then for it to go down. All right. Third time is a charm, I have heard. Has anybody else heard that saying? Yeah. Okay, so we see all of the old subscriptions coming in. Probably should have flushed that out. That's good. So this is picking up all of the old published messages that I put on top of the topic, right? It's actually reading off that topic now. Well, let's go kill Docker, the Docker state store. And what we should see is it's gonna start having issues, right? So now you can see, okay, this isn't working very well. We're having issues. And then we can see it's retrying, and then now the circuit breaker is open. So it's essentially gonna continue to retry until that state store comes back up because of this resiliency policy. So you can go in, you can set retry policies, timeouts, and you can target particular components like the state store, which is why this is running. And if I was to go and revive that state store, and think of this as being really good for transient errors, especially when you're running in a cloud provider, you can see that it's going to recover and start persisting again, which is really nice without any of that retry logic being hard-coded in. So I have one more minute, which makes me really bummed because I wanted to kind of show you what it looks like running on Kubernetes, but it's pretty simple, right? I did a Dapr init, but instead of initializing it on my local machine, I passed in the Kubernetes flag. And so if I just do a kget ns, we can see where we are. All of the control plane gets deployed to the Dapr system, and then I basically have another namespace, which is the order app, which is where all of the code is running. So if I get my pods, I see here that there's 2 pods running. Both of these have 2 containers, the app and the sidecar. So I would see those sidecar logs. It would load my components. If I do kget components, I can see I passed in the pub/sub AWS in the state store. And once again, I could swap these out. I'm using Kubernetes secrets on Kubernetes. And the last thing I wanted to do, just before I round it out, is show you kind of what Dapr provides from a visibility perspective. So this is one of the products that I work on at Diagrid, but you can see here I can actually get app visualization between two apps. So when I start making calls, I can actually isolate in. I can see all of the different components that are running. I can do Dapr upgrades. So this is just a really great way to get visibility, very similar to the open source Dapr dashboard. Probably should have sent some requests in to be able to see that app map visualized, but yeah, ultimately this just gives you really good taste of all of the Prometheus metrics, the tracing that's available, and even out of the box, I get Zipkin. So if I take a look here, this is running out of the box on my local machine. When I did that Dapr init, it goes ahead and sets up tracing for me. So I get tracing out of the box end to end, and you can plug that in with basically any tracing provider. So thank you all so much for your time. It's been a pleasure. I know I'm coming up on the end. I tried to pack in as much as I could. If you're interested in learning more about Dapr, I would really encourage you to get involved in our Discord community. We're always looking for contributors and just people who are interested and want to learn more about the project. So interested in Dapr, reach out to us at Dapr, and then if you're interested in working with us at Diagrid, please feel free to reach out to me and connect directly. So thanks for your time. Really appreciate it. Yeah. Hope you enjoy the rest of the conference.